Hey, welcome to this video on counting significant figures. We are only going to be talking about counting, so if you're interested in learning about math with significant figures, that's going to be a different video. This is literally only going to cover what you see on your screen right now. All right, so significant figures is this concept that not all measurements are created equally. Some measurements are very exact. An example of that might be a volume measured with a graduated cylinder, because a graduated cylinder, has a base and it's got like all these little lines on it that help you measure a very exact reading. So you might measure that the water in here is like 125.2 milliliters, okay? Other measurements are much less exact, okay? So a less exact measurement might be with a beaker, and maybe it says like 50, 100, and 150, and your water level is like right here. And you're just kind of guessing, maybe it's like 130-ish, but I'm not really sure. So even though it might be the same amount of water in these two containers, this measurement is much more exact, and this one is less exact. And we see that in the number of digits that are recorded and the place values that they go to. So what we're going to talk about is how do we look at numbers and know how many sig figs it has? So again, this concept where we are talking about the uncertainty is represented by this concept called significant figures. The more significant figures in a value in a measurement, the more exact and certain the measurement is. All right, and so again, the number of sig figs in a measurement, such as 2.535, is equal to the number of digits that are known with some degree of confidence. So if we bother to write down a measurement, it means that we actually know those digits. Okay, so we're going to talk about the rules now for counting significant figures. Rule number one is very easy. Non-zero digits always count as significant. So an example of, and actually, I'm going to talk about rule number two also because they're both so easy. Rule number two says sandwiched zeros are also always significant. So I'm going to give an example of a number that covers both rule 1 and 2. So let's look at the number 402. All right. So rule number 1 says that the non-zero digits are valid and significant. So that's the 4 and the 2. Rule number 2 says sandwiched zeros are significant. That right there, that 0 is an example of a sandwiched 0. So what we see here is that all of these digits are significant. So we would say 3 sig figs. 3 would be our answer for counting the number of sig figs in that number. All right, rule number 3 is not so bad if you take it literally. Zeros at the beginning of a number are never significant. All the numbers that are ever at the beginning of a number, all the zeros that are at the beginning of a number are never significant. So really the only time you're going to see zeros at the beginning of the number if it starts with 0 point. So a number that's less than 1. So like 0.0000359. Okay? 3593. I'll give it one more. So these zeros at the beginning do not count. Nope, 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 nope. They're not significant. Okay? They are simply placeholders so that the 3, 5, 9, and 3 are in the right place value. So the 3, 5, 9, and 3 count as significant because they are non-zeros. So this number here has 4 sig figs. So again, zeros at the beginning of a number are never significant, period, the end. There is no more information to that rule. Number 4, again, if you take it literally, is not too bad. Zeros at the end of a number are significant only if you can see the decimal. So I literally mean, can you see it with your eyes? If you can, it counts. If not, it doesn't count. So an example of, here we go, rule number 4. Okay, what if I give you the number 400.0? Okay, well, here they are. Look at these zeros at the end of a number. I don't care where they are in relation to the decimal. I just care that I can see the decimal. So since the zeros are at the end of a number and I can see the decimal, they count as significant. That means they're measured. It means we know that this is exactly 400. So this number 400.0 is 4 sig figs. Now, if I write that number a little bit differently, what if I write that number, I'll go back to black. What if I write it like this, 400? If I write that number, what I really mean is 400-ish, maybe, I'm not really sure. And so that actually only has 1 sig fig, the 4 right there. The zeros at the end do not count because I cannot see the decimal point, and that's what rule number 4 says. All right. Just a little side note here. This section doesn't affect how you count the sig figs, but it is worth noting that exact numbers have an unlimited number of sig figs, and they we don't say that it even has sig figs because it's not measured. So for instance, if I counted something like 12 students, I don't mean like 12, because I mean 12 students. You count a number of people and you know it exactly. It's either 11, 12, or 13. There's no partial. So that's an exact number, and we just don't talk about sig figs with counted numbers. Same thing for defined conversion factors, like 1 meter is 100 centimeters. I don't mean that 1 meter is about 100 centimeters. I mean that's exactly 100 centimeters. So again, that's not a measured thing, so we don't count it. Okay. And then the last little side note here is that if a number is in scientific notation, the 10 to the power of something part is not counted as significant. That does not affect counting your sig figs. And so you just look at the part that comes before it. So for instance, if I had the number, here's an example. If I had the number 4.2 times 10 to the 6th, this number has 2 sig figs, the 4 and the 2. So 2 sig figs, that's my answer. The times 10 to the 6 is just like a decimal mover. It's not really part of the measurement. So that's just a little side note. Okay, so we're gonna do a couple practice problems and be done with this. So again, y'all, our only task right now is count the number of significant figures. Okay, so what I'm gonna do is I'm gonna highlight in yellow the significant figures in each number. So number 1, 626. Every single one of those digits is non-zero, so that number has 3 sig figs, all of them counted. Moving on. Number 2, the number 0.55. Well, the 5 and the 5 definitely count. This 0 is at the beginning of a number, and what did Rule 3 say? Rule 3 says zeros at the beginning are never significant, so I'm not going to count it as significant. So my answer is 2. The 5 and the 5 are my significant figures. Next up, the 8 and the 8 definitely count as significant. What about those zeros at the end of a number? Well, rule number 4 here says zeros at the end are significant only if you can see that decimal. I can't. I cannot see that decimal in the number 8,800 written the way it is, so they don't count. So only 2 sig figs. Cool, moving on. Number 4. Well, the 6, the 2, and the 1 definitely count. Okay, this 0 here that I'm drawing a little arrow towards, that is a sandwich 0, so I'm going to count it. What about those zeros at the beginning of a number? Well, Rule 4 says zeros at the beginning of a number, Rule 3. Ooh, Miss Hammer. Rule 3, zeros at the beginning of a number are never significant, so they do not count. So 4 is our answer. All right, I want you to try problems 5, 6, 7, and 8 on your own while you pause the video and then come back to check your answers. All right, so I have highlighted the digits that count as significant here. So number 5 is 6. The decimals or the zeros at the end counted because I see the decimal. There it is. Number 6, all of them count, so it's 6 sig figs. Number 7, all of them count. That 0 at the end counts because I can see the decimal, so 4 sig figs. And then same story with number 8. That 0 at the end counts because I can see the decimal, so all 5 digits count. All right, so that is how you count significant figures. Make sure you practice with this a lot. If you need any extra help, come ask your teacher. We're happy to help you. Thanks for watching.